Welcome back to the show. Today, we are joined by Sayon, who is Manager of Data Science and Engineering at Delivery Hero. Today, we'll be diving deep into lean experimentation and decision science when humans are kept in the loop, why it's important to consider this and all the things that can go wrong, and the developments of more data that will be introduced. Great episode from Sayon, who's an avid community member and a regular speaker at events. Please enjoy. Why is it important that we keep humans in the loop when it comes to data science?
I think it's a very critical question given that we are talking about automating decisions. And at the end of the day, when you are running a business and you want to add business value, at the end of the day, your consumer or your customers are humans at the end of the day. So I think it's very critical that you have an open feedback loop with the humans and the people who are actually involved in such a data science or a decision science project or an experiment.
And what are the challenges that arise from this?
Yeah, I think in when you are applying data science or any kind of ML AI on a product which is a bit more application based or something like this, you have access to a lot of log data with which you can play around and explore. But when you do not have a application per se, but your solution is being directly used by the people on ground, then gathering this data becomes much more trickier and it becomes much more complex. And especially when you go from regional to different regional teams to different across the globe, then you are not only talking about regional or cultural biases, but also several other complexity comes out around the data itself because you are directly getting it from the data. And yeah, I mean, if that helps, I could provide an example of such a scenario to explain this a bit further.
Yeah, go into that. Give us some context.
Yeah. So, for example, at Delivery Hero, we have this problem that we solve around picker scheduling. So what does it mean? Like quick commerce, which is basically accelerated e-commerce, bringing you groceries out to your doorstep under 15 minutes, 20 minutes, depending on where you are in the world. In order to do that, I mean, why we need picker scheduling in the first place? As you can imagine, when you go ahead and order something in the grocery app, someone is getting a notification in a warehouse somewhere in that city, and then there are pickers running around to collect those and then grabbing them and then giving it out to the riders, right? Now think from a perspective of you are the store manager of that warehouse. How do you decide how many pickers should I have this month? Or let's be more granular. Today on a Monday, in the morning, how many pickers do I need? In the afternoon, how many pickers do I need? If you are having less pickers, you are losing out on orders. You are not able to fulfill the delivery time. If you are having more pickers, then you have ideal time of the pickers, and then your overall operational cost is increasing. So how do you hit that ideal number? And that's where we come in, trying to provide a solution there. And in this case, as you can imagine, that okay, whatever, if you consider it to be a black box, however, we are doing everything to provide optimized pickers on the ground. How do you know this is working? Because you are not doing this experiment on an application or a web application. You are actually providing this schedule. And there are humans, I don't know, in Argentina, sitting there using your schedule and saying it's working and not working, right? So that way, this brings in a bit more complexity around how you run these experiments or design these experiments to be lean. Yeah.
There must be so many variables there when the humans are, because day to day it's different pickers have different abilities. So how are you putting this all into a model?
I think there is, yes, you're right that one part is around the picker productivity, but what also matters is in a warehouse, you as a customer are ordering an order. So you can imagine one of the most important thing that comes into the picture is you are doing a customer order forecast. You can use different kind of machine learning approaches to do a customer order forecast. But the challenge here is actually that's kind of the easiest part of the whole problem. when you do the demand forecast or the order forecast. The tricky part comes in when you have so many activities in the warehouse that the picker needs to do, which is beyond just customer order forecast. So for example, doing a cycle count, knowing how much do you have in the inventory. When the supplier comes in, you need to receive the goods from the supplier in your warehouses, doing some ad hoc cleaning as and when required, doing a round of expiry checks on your products to see if things are in place and if you need to throw away something or to get more of something, etc., etc. So along with some deterministic activity, there's also a lot of stochastic activities involved in running a warehouse, doing the inventory management for the warehouse. And this makes it quite challenging to have all these inputs modeled in for the optimization problem. And in this case, yes, there are certain data points that you get in our database via applications that the pickers use on the ground. So for example, I don't know, when you are doing cleaning, you keep logging when you do the cleaning. And then maybe you have the parts data that how did this person do the cleaning in this warehouse over the last 6 months. And then you see that, okay, usually during this time, the cleaning happens. So I can predict that there's a pattern and I can predict that. But when you think of activities like getting goods from suppliers, yes, there is a schedule, but traffic in Dubai is very different from traffic in Vienna, for example. So it becomes very tricky to predict that. So in this case, it's a lot around getting more inputs from the local teams to understand, because you're building a global solution, getting more inputs from the local teams on these variables, on what fits for them, and then modeling it or putting it as a part of the solution there in order to recommend optimal pickers.
So are you having a centralized prediction model and then adapting, or are you working the other way around?
It's a combination of both. So when it comes to more customer order forecast, you have all the data and you can do a demand forecast or an order forecast. But when it comes to these things, which are very different in country to country, those are the things where we have to think a bit backward and take these data points from the local teams and then go ahead with it.
Is there huge differences between the different regions?
Quite a lot, in the sense that there is a difference in culture, there's a difference in way of working. There is a difference in shift lengths and how much can a picker work, or I mean, in Europe, it's super common for also to students to be a part-time picker and work in a warehouse, but that's probably not so common in Argentina. And I don't know, things like, for example, the inventory itself, right? The scheduling, the example I was giving you. For a supplier to be on schedule all the time, it's much more following the schedule in Singapore compared to in Turkey, just because of the demographics, just because of how the traffic situation is and the unpredictability is. So there are these quite a lot of differences for which you cannot build one solution for everything. But at the same time, you don't want to go and build custom solutions for everyone. So it's kind of a hybrid approach here to see how is the effort impact ratio here and maximize the impact there. Yeah.
And just to go back a little bit, so stochastic activities, what are those?
So when it comes to stochastic activities, for example, one example, you can have a regular cleaning done in the warehouse, but you have a box of milk that spills. Now, whatever customer order would be there, one of the picker needs to go in there and then take care of that, right? So that's an example of a stochastic activity. I mean, in general, when suppliers are not able to follow the schedule and receiving of goods happen at an odd time, that's also another example of a stochastic activity, because it ends up being quite random.
So it's predictable because something's going to happen, you just don't know what and when.
Yeah, and data science or machine learning only works when you can detect a pattern. For the activities for which you don't have a pattern, that's where you have to go with a bit more rule-based approach by taking help of your local team. You cannot really predict things because there is no as such prediction to be made with the patterns out there.
Can you predict that something unpredictable is going to happen?
That's a tricky question. I think depends on the problem itself. I was about to say no, but then I think one can come up with examples where you can also predict that. And if you are able to predict the unpredictability, as in if you're able to predict a buffer that, okay,
Yeah.
during the day, this 20% of the buffer is where I cannot predict. Even that piece of information is useful because then you can focus your predictability on the first 80%, and the rest 20% has to be either rule-based or give the responsibility to the humans out there to make a decision there.
Would this be could you classify these events as unclean data, or how do you name and work with
Yeah,
this?
it's a combination of both. So there could be, so for certain activities there could be a good data, there could be unclean data, there could also be no data. So an example of an unclean data is a picker logs in and logs out, right? And there could be a warehouse where, I don't know, one fine day the picker forgot to log out, and there might be an auto clock out mechanism after, I don't know, 15 minutes, 20 minutes of the scheduled time that you would be logged out.
Yeah.
But then how do you take this extra time into account? Is it the overtime? Is it, of course, you can also build in more features to track everything. And that depends on the maturity of the product you are building. But in early stages, you always have this clean data, unclean data, no data. And then it's super important to differentiate those so that when we are building any kind of predictive or any kind of preventive modeling there, you want to take the ones where you have data and not the ones where you have unclean data and no data. And of course, work in collaboration with the software teams to educate them that, hey, these are the things for which if we had data, we could do this magic. And then can we build an application to gather those data?
So how much importance is there on the education of the end users, the humans who are clocking in, clocking out, doing the picking, the managers?
Yeah.
Where does that come in?
Yeah, I think that comes in more in the lines of, you can imagine you build a solution. How do you know this is working or this is helpful?
Yeah.
So if it was a, I don't know, if you were building a traditional web application or a mobile application, you can set up, you change a button from green to blue, and then you can split the traffic in a classic A/B testing manner. And then you can see that, hey, my traffic who are using the blue button seem to be happier. They are clicking more compared to the green button.
Yeah.
And then you have all the data from the log. You don't really need to talk to the people who are actually pressing the button because you have the data already. But in this case, that's why designing an experiment becomes a bit more tricky and challenging, because you're not doing it in an application, but you have the end users who are actually implementing your solution or adopting your solution. And this is where it becomes important to have the input or the feedback from the people itself. So in this case, one approach is having very comprehensive Google surveys to understand which time, which day did the schedule was suboptimal in this case.
Right.
And why was that? Was it due to something unpredictable, something random happened? The truck broke down, or I don't know, the electricity went off. Like an example of stochastic activity, right? We hear situations where the electricity goes off. What do you do then? The warehouse is shut down and you cannot predict that, and at least as of now. So to understand what were the reasons of that suboptimal, one of the reason could be also the model did a bad job. So to be able to gather those reasoning and then to classify them, which are the ones we can actually tackle and which are the ones we cannot tackle, it is out of our hands, and then taking those tackleable problems, subset of problems, to iterate further upon that, right? So this is where one example is a Google survey link and it's, although it sounds like a survey, but I think a lot of effort can go into the survey, because you need to know what hypothesis are you trying to confirm.
Mm-hmm.
And based on that hypothesis, you would probably design your questionnaires, because you want very close-ended, specific answers to your questions.
Mm-hmm.
And it cannot be very subjective. It cannot be very open-ended, because then you would need humans on this side as well to read them and to make sense of them, right?
Mm-hmm.
So that way, any kind of questionnaires or user surveys becomes very critical when doing an experiment.
How much data are we disregarding when it comes to either the events or the surveys?
It depends a bit from region to region.
Mm-hmm.
So also on the maturity of the warehouses, different areas have different maturity of the digitalization there.
Yeah.
But in general, we try to make use of as much data as possible. That's one of the top priority, to
Yeah.
see how the data can be interpreted in different forms. And the most important part of the data is also, when I was talking about confirming the hypothesis, to make sure that we define certain key performance indicators beforehand.
Right.
Because you cannot really rely on the store manager only telling you that we love the schedule or we don't love the schedule, because that's also something more, you want that to be more tangible, right?
Mm-hmm.
So that way you also need to have several performance indicators there to be able to manage that. Yeah.
So say you're setting up a new warehouse in a new region. Talk me through that process. Where'd you start?
You mean you open up a warehouse and
Yeah.
then yeah, so traditionally I would start by relying on the store manager to
Okay.
schedule the pickers. We
Mm-hmm.
don't come into the picture. Like, you start with a baseline, right?
Yeah.
Because at the end of the day, if you are a store manager, you have some idea of what you are expecting, and you do your human trial and error run.
Mm-hmm.
It becomes trickier only when the store gets higher and higher. I mean,
Okay.
if you have, I don't know, 200 orders per day, 250 orders per day, you can manage.
Mm-hmm.
But when you look at countries like Middle East, countries in Middle East, you have orders which go as high as 1,300 orders per day, 1,500 orders per day in single warehouse, and you have a bunch of warehouses there.
Yeah.
So there it becomes tricky for humans to take in. So that's also one of the reasons that when you run the experiment, it's important to understand that where would your solution make the most business impact.
Right.
It might not have the same impact in all the warehouses of all the regions. So
Mm-hmm.
let's target the ones where we can help the most, and then slowly roll it out to places where it's kind of nice to have, or good to have. And when doing experiments, this is also becomes, when you design the hypothesis, it also becomes important that you decide what is your sample space there. Yeah.
Mm-hmm. And then is it once that model's set up and it's performing well, is it kind of left to its own devices, or how does it improve?
Yeah, so it's also a continuous process, in the sense that you can imagine in the warehouse itself, a lot of operational processes improve over time.
Yeah.
So by that, I mean, today, say you're doing inventory count, cycle count, where you want to count how many milk cartons do I have in stock today, right?
Mm-hmm.
Now, in warehouse a picker might be going randomly across the warehouse to find out how many milk cartons I have.
Yeah.
In warehouse B, maybe it's a location-based inventory. By that, I mean things are categorized super nicely by location. And you have a map for the warehouse where it's super easy for the picker to go and know this is the section of milk, and I will only find milk there. I guess
Mm-hmm.
all of us struggle when we go to a large new grocery store, right? We love
Yeah.
going to a grocery store where we have the map in our head. But if
Mm-hmm.
you're thrown into a new grocery store, I am running around 5 minutes to search for the eggs, right?
Yeah.
So by this, what I mean is, different warehouses are also at different maturity level, and these are constantly improving. So as these improve, the model also needs to take that into account in some
Mm-hmm.
sense. So there also needs to be always a question around if I'm having a drift, if I'm having some kind of a data drift or a model drift. But in this particular problem, I think this is a bit more long term. It happens over a period of time. It's not a problem where every day you need to retrain your model or every single day. It's more like keeping a check on, are the operational tools in these warehouses drastically improving? Did they buy a new fancy machine to do something? Or now do they have cameras in the warehouses to do something fancy? Okay, in that case, maybe we need to revisit the approach for this warehouse. Yeah.
So is it a case of the models getting better because we're getting access to more data, like cameras, IoT sensors, all these kind of things?
That's always the case. I mean, the more data you have, the more sophisticated you can get your model at. But yeah, what's important is, I think, it's always a fight between, yes, I need more data to do something, but then when is it enough to start a data science project? And that's always an interesting problem, especially when you, I don't know, when you start a startup or start a new business and you want to decide that I have 3 software engineering teams. Is it a good enough time to bring in a data science team? Someone might tell you that, no, you should wait 1 more year till you have more data. And another person might say, no, this is already a good time to bring in a data science team to already use what we can do with the data that we have. So as a data scientist, I would always be craving for more data. But then that's a known thing. But then it's also fun to make use of the limited data you have for a given problem, to extrapolate it and to see what you can make the most out of it. Yeah.
More creative license.
Yeah. And I think at the end of the day, I think experimentation is very important, to be more experiment driven. And how you design hypothesis. So in this specific example, the process of designing an hypothesis, defining what could be the KPIs or the performance indicator for such a problem, that's also a very interesting product come tech problem that we tackle and go through the journey. Yeah.
Nice. So within experimentation, what are you excited about at the moment? What's coming up? What are you trialing?
So I think when it comes to this picker scheduling project, I think we are almost at the end of all the experimentations in different countries. And right now it's more around doing the rollouts, that things work, and we go ahead and we roll it out. But while you do this, I mean, this is a more engineering part of the things. While you do this, there are other problems that come in that you can tackle beyond the picker scheduling, right? And if you're curious, like one example is, for example, when as a customer you order, I don't know, 1.5% fat milk, right? You, for whatever reason, that product is out of stock and there was not a sync, and you could see it in your app. And now when you want to order that, you want to recommend the customer an alternative. So when you provide an alternative, ideally you would want to provide, I don't know, a 1.5% milk of another brand, or 3.5% milk, right? But probably not, I don't know, you probably won't replace it with a bottle of whiskey or something like that, right? That would be totally random. and
For some people.
So yeah. So how to make these product recommendations for item replacement better, right? So while we move from one experimentation phase to a rollout phase, then you have other data science problems coming into the domain, and then you try to tackle this, right? So yeah, this is kind of the current state. And also when it comes to picker scheduling itself, you can also imagine a lot can go around. I did not talk about the performance indicators, how you define the experiment in this case. We can talk about it in a moment. But you can imagine one of the important thing is picking time, right? If your picking time is higher for a picker in a warehouse, you will get your grocery later. As simple as that. How you can improve picking time. So for example, we were talking about location-based inventory, but imagine picker route optimization. Based on a list of 10 products that you have on your app, or when the picker opens, he or she sees that, okay, I have these 10 products to collect. Can I, as a data science team, order those items in a certain way so that the route in which the picker would go would be more optimized. He or she doesn't has to do zigzag, right?
Yeah.
And for that, of course, you need data in the sense of what is the layout of the warehouse. Where do you keep milk? Where do you keep eggs? Where do you keep something else, right? So this is like another problem to make picker scheduling even better. And then if you have this, essentially, you would also in the schedule need less pickers to work with. So your whole operational cost reduces and you are able to still fulfill the orders. Yeah.
So sounds like a big focus on efficiency.
Yeah, it's all about when it comes to quick commerce and when it comes to quick commerce and these kind of problems, it's all about operational efficiency, right? I mean, the more efficient you are, the faster you can deliver the order. Or even if you don't want to deliver it faster, say, I don't know, certain country, certain region doesn't need the order to be delivered in 20 minutes. It's okay with 45 minutes.
Yeah.
In that case, you can reduce your operational cost by having less pickers. So yeah, that's one reason why the efficiency becomes very important. Yeah.
And you mentioned the performance indicators you wanted to talk about.
Yeah. So I mean, when defining the experiment, right? I mean, it's very important to do a experiment with a hypothesis which is like smart, like with the smart framework that things needs to be specific, measurable, achievable. They need to be relevant to the problem and also time bound. How long do you want to run the experiment, right? And you can imagine that if I want to build a hypothesis for this experiment itself, I would probably make it something like change the picker shift schedule, which is my element of test, from the manual heuristic approach that the store manager uses to a more demand forecast optimized approach. So you have the element of test, you have the from and to, where to is your proposed or the new methodology. While you can also have some constraint. In this case, the constraint would be while sustaining the customer experience, because you can essentially recommend very less pickers, and that will bring down the cost of the warehouse. But the customer experience will be dipping as well, because you won't be able to deliver in half an hour anymore. So that's the constraint part, that while this is happening, and the hypothesis would be doing all of this will affect my KPIs, the key performance indicators. And for this example, it's end of the day, it comes to reduce operational expense. But when it comes to operational expense, what you can imagine, even this could be broken down into 3 smaller KPIs. Like one, optimize the daily man hours, the total man hours needed daily in a warehouse to run. You want to optimize that. I say optimize and not reduce, because you want to keep the customer experience, right? You want to diminish the picker idle time. So whenever the picker has nothing to do and he's just waiting because he has nothing else to do. So that means you want to, that's something you can track, and that's something you want to reduce. And you want to boost picker utilization. And by picker utilization, I mean, you can imagine it to be the number of orders delivered per day and the total man hours you have in a warehouse, right? And this ratio, if you can increase, that means you are increasing your productivity, like less pickers delivering more orders, right? So yeah, and then you design this hypothesis, you roll out the schedule, and then you try to monitor it for whatever number of days you need based on the number of orders you have or the sample size. And then do you see for all these 3 metrics, how is it going on? Is something increasing, decreasing? And if it is not performing as is, then yes, I was talking to you about Google surveys, about getting the feedback, and then trying to deep dive, okay, what is the problem here? What can we iterate and go forward again? So I think this lean experimentation cycle is, I mean, we use it for almost everything we do at Delivery Hero, beyond quick commerce, be it restaurant business or any data science problem. But in this problem, I think the humans also play an integral role in the experiment with all the questionnaires we ask them and the feedback that we receive. Yeah.
You explain it so well and make it sound so straightforward, but in reality, it's certainly not.
Well, I think,
go on.
yeah, I think no. I mean, it sounds easy, but yeah, it's more like the moment you bring a bit more structure to the way you do this thing,
Yeah.
things tend to fall in place, or you are forcing things to fall in place, because there's a lot of chaos when it comes to inventory management and operational research, and you have to be a bit structured around defining these. Otherwise, you are lost in the chaos, right? Yeah, yeah.
Absolutely. But we really appreciate you coming on and joining us today. For those who want to keep up with the stuff you're doing, you know that we know that you speak at conferences. How can people get in touch and keep up to date with what you're doing?
Absolutely. I think you can connect to me on LinkedIn, and yeah, I'll be more than happy to stay in touch and chat more around interesting topics.
Amazing. We appreciate you joining us, Sayan. Thank you.
Thank you so much, Matt. Nice talking to you.